Hey guys, welcome back to another lesson of lesson 36, I think. And we're starting off with percents and decimals. Write the following decimals as percents and percents as decimals. So starting off pretty easy. 284%. That would be, in decimal form, that would be 2.84. And then let's do a decimal one. We have, so what we just did was number 1. Let's try number 8. Number 8, 0.28 is the same thing as 28%. Once you finish those, we can move on to the next page. Convert the following measuring units. So, oops. So, let's do number 1. 41.5 cm. And we're trying to make that into millimeters. So, there are 10. Let me write that better. There are 10 millimeters in one centimeter. So what we want to do is, this is being multiplied by 10. So what we want to do is multiply it by 10 here too. So 41.5 centimeters times 10 is 415 millimeters. Yeah, pretty easy. Also, there are 100 centimeters in 1 meter, just for reference for the other problems. Yeah, let's actually just do one right now. Number 2. 6.6 meter is equal to, and since there are 100 centimeters in 1 meter, we're gonna multiply 6.6 times 100, and that equals 660 centimeters equals 6.6 meters. So the answer would be 660 right here. Alright. Moving on. Circle. So if you remember, the area of a circle is pi r squared. So what we want to do here is, for number 1, the radius is 5.9, so the area is going to be pi 5.9 squared. So just do 5.9 times 5.9, which equals 81. 45 plus 8, 53. 0. 45. 45. 29. I think this was a 5, right? Yeah. And then add them. 1, 8, 14, 3. So 34.81. 34.81. Okay. So area is pi r squared. Area for this triangle is going to be pi times 5.9 squared, which is a equals, what was it? Pi times 34.81, I think. I think that's what it was. I forgot already. So anyway, yeah. So how you would write this is 34.81 pi. I think it was 34.81 pi. Anyway, yeah. Moving on. we have a coordinate grid. Draw a trapezoid. Let me zoom in a little bit. Draw a trapezoid with vertices -1, 7, 7, 7, and so on. Then move it 3 units down. What are the new coordinates? So, -1, 7. 1, 2, 3, 4, 5, 6, 7, right here. Then 7, 7, 1, 2, 3, 4, whoops, 1, 2, 3, 4, 5, 6, 7, should be right there. Then 2, -6, 2, 3, 4, 5, 6, right here I think. Then 0, -6, right there. So this is our trapezoid. That's a really bad drawing. Sorry about that. And then move it 3 units down. So you can move each of these units or these points 3 units down, and then your new trapezoid would look something like this. And then what are the new coordinates? And then you could all look at them and then figure out what the coordinates are. But that kind of looks that kind of takes a longer time. So here's a faster method that's more easier. So we have these points, and when we move something 3 units down, what are we doing to the y value? If we're moving something 3 units down, then we're subtracting the y value by 3, right? So, for example, if we have -1, 7, right here I think, and then we move it 3 units down, it's going to be -1, 4. So all we did, we moved it 3 units down, and all we did is subtract the y value from 7 minus 3 to 4. So in order to figure out the new coordinates after moving it 3 units down, all we have to do is subtract each of these y units by 3. So the new coordinates would be -1, 4, 7, 4, 2, -10, and 0, -10. And look, I don't even have to draw anything. It's pretty easy. So that's just a faster method, an easier one that you could do. So yep, after you solve all of these, I'll show you the answers. Right here. Alright. See you guys later.